All right, here we have a 4 by 4 matrix determinant. How do you tackle it? Well, you do it by either row expansion or column expansion. That's the only way, unfortunately. So let's try to do expansion by one of the rows. Okay, which one do you want to pick? There are really many different possible choices. Huh? You want first row? Okay, let's just do first row. The options are first row or first column, or the last column or the last row. You want to pick one of these four because those are the ones with lots of zeros. Okay? If you have lots of zeros, then it makes the expansion simpler. Okay. So let's do the first row. Okay, how do you do this? Well, you first write down the number, the element, times the minor matrix, which is the matrix obtained by deleting the row and the column containing that element. So this would, if you delete this column and that row, you end up with this matrix here, which is 2, n, 0, negative 1, 3, 1, 0, 2, negative 1. And then you go to the next element, which is 2. Again, let's try to delete the first row and this column. What are you left with? It's m, n, 0, and then 0, 3, 1, 0, 2, negative 1, 0, 2, negative 1. And then we have 0 times something, 0 times something, I don't care. Okay? And then once you write in this format, then you have to apply the checkerboard of signs, which always starts from plus. So the checkerboard of signs for 4 by 4 will look like this. And since we're expanding with respect to the first row, when you apply the signs, it should be plus, minus, plus, and minus. Okay. Now let's continue on. I have to expand this. Which one do you prefer? I guess it doesn't matter. Let's just use the first row. So for this one, it's 2 times. The minor is 3, 1, 2, minus 1. And then n times negative 1, 1, 0, negative 1. Negative 1, 1, 0, negative 1. And then you have 0 times something, which I don't care. Still, you have to apply the checkerboard of signs, plus, minus, plus. So that's what happens to the first one. Now for the second one, it's negative 2 times. You have to compute this. And for this one, I only see one choice, which is the best. The first column. Because that has 2 zeros. No other column or row has more zeros than that, right? So I'm going to use that, which means it's m times the minor matrix is 3, 1, 2, negative 1, and 2 more zeros, which I don't even want to write. And it's plus, minus, plus. That doesn't matter here. So that's what we have. Now let's continue on. What's that? This is then for 2 by 2, you can still do it if you want. If you forgot how to compute the 2 by 2, you can still expand by the first row and say 3 times the minor is negative 1, right? And then minus 1 times the minor is 2. You can do it that way, but the quicker way is to just say it's AD minus BC. Right? So 3 times negative 1 minus 1 times 2. What's that? 3 times negative 1 is negative 3. 1 times 2 is negative, positive 2. But if you do negative 3 minus 2, you get negative 5. So you get twice of negative 5. Here, negative 1 times negative 1 is positive 1 minus 0, so it's just 1. So negative n times 1. Okay, and then that's 0, so that's gone. Minus 2. Here, negative 3 minus 2 again, so that's negative 5. So m times negative 5. And finally, this is negative 10 minus n plus 10n. So that's how you do the 4 by 4 matrix determinant.